Hey folks, great to see everyone. I'm Charlie. I'm a product manager here at Oasis Labs.
And hi, I'm Nikhil. I'm an engineer at Oasis Labs.
At Oasis Labs, we're building great data privacy and security tools to help businesses and customers leverage the Oasis network to better control and protect their data. So we're excited to have you tune in for this session. Today, in this video, we're going to be talking through one of the main tools that we're building at Oasis Labs called Parcel. And so Parcel is a set of privacy-first data governance APIs designed to give customers better control and oversight into how their data is used. On one side, for developers, Parcel makes it really easy for developers to securely store sensitive user data, define and enforce usage policies over that sensitive data, share tamper-proof logs of access histories with their end users, and easily deploy applications in isolated compute environments, what we call secure enclaves, for privacy preserving analyses. On the other side, Parcel also makes it great for end users because it helps end users easily manage how their data is used, control access, grant permissions, see history. We have what we call the Oasis Steward app, which is a web UI app that lets end users do all this to manage their data. And what we're really excited about with Parcel is that it allows businesses to tackle one of the most challenging issues of our time, providing strong privacy guarantees to their customers without compromising the utility of their products. One example of this is Nebula Genomics. They're a consumer personal genome sequencing company, and we've partnered with Nebula Genomics. They're integrating Parcel, and what that'll do, it'll give their end users better privacy and control of their genomic data. We're going to be launching the beta version of this in the coming weeks. And if you're interested, you can learn more about the Nebula and Parcel integration in one of our other videos from today, where we talk with Nebula co-founder George Church. So we're here to show Parcel. Nikhil, tell us a little bit more about what we're going to be demonstrating today.
Yeah, thanks for the great intro to what Parcel is, Charlie. Today we're going to show you how it actually works with a mock app named BlockCred. So what BlockCred is it's an application for credit scoring using our confidential compute platform. And we're going to show you how to use Parcel to generate a credit score.
Cool.
So this is going to have a bunch of different components. First, we're going to talk through account linking using Parcel. Then we'll show you how to upload data for users. And then finally, we'll actually go through running a confidential compute job.
Awesome. So let's hop into the first part. Let's check out what this account linking looks like. Cool. So the first part that Nikhil is going to walk us through here is account linking. So this helps developers take their user accounts and then have their users create Oasis Steward accounts to manage their data, control permissions, view access history, and for developers to be able to link their Oasis accounts to their end users' accounts. So we have the screen here, which is part of our onboarding for our BlockCred app, and we have our users who are going to sign up for our app and then sign up for an Oasis app and link their accounts. So Nikhil, tell us how this is done.
Yeah, so let's take a look at some code. So what happens when you are trying to link your account is that we use the standard OpenID connect flows, and that's going to trigger a flow to accept user consents via our Steward web application. And users that accept this will be redirected back to your application, where you can now have an Oasis blockchain managed identity for linking with any associative data in your backend. So yeah, so like as you can see here, there's a bunch of config data that's pretty standard with OpenID Connect. And once we specified this, we can go ahead and run the flow super easily. So yeah, as you can see, it's just a few lines of code, pretty standard. It uses a JavaScript library named OIDC client, and very simply just creates a sign-in request. And once we click on this button, this sign-in request will trigger, and the account linking will kick off. Yeah, let's go ahead and see what that looks like.
Cool, let's try it out. So we'll click over here, get started with Oasis. This will kick off the account linking flow and dump us off to the Oasis Steward app. We'll sign in, we'll create an account or sign in to Oasis Steward. We'll pick our account here. And then it's going to ask us if we want to share permissions with the Blockcred app. So this is saying, do you, as an end user, Charlie, do you want to share your Oasis account with the Blockcred app so that they can then upload data on your behalf? And then if you give them permission to later, then access that data. So I'll say, sign up for Oasis, and then I will say I'm going to share my Oasis identity with the Blockcred app. And this will dump us back to our app, Blockcred, and then we'll kick off the second part of the flow here where we ask users in more detail for exact permissions to use their different pieces of data for what our app is trying to do. So specifically for this example, we're going to ask users for access to some of their financial data so that we can calculate their credit score. And so this screen is where developers can be a little bit more granular and really transparent with their users about what data they're going to collect and how they're planning to use that data, so users can make a good informed decision as to whether or not they grant permission. So this sounds interesting, this sounds valuable to me as an end user, so I'm gonna say yes. I'm gonna grant permissions. This is going to store a record of this relationship now between this app and this end user on the chain. And so there'll be an immutable log history of the permission that I've granted, and I can always come back later as an end user and change my mind and revoke their permission. So it's saved off to the chain all officially, and I can complete my onboarding. This sends me now back to the Blockcred app, back to the third-party app, the developer's app, and we can see here the user ID that the Blockcred app got back for me now that I've completed the account linking flow. So Nikhil, how did this work behind the scenes?
Yeah, so behind the scenes, after all of the consents and everything, we returned to the app via this callback that is part of the OpenID Connect flow, and that retrieved a JSON web token, which is your ID token. And in that ID token, once you decode it, the subject, this dot sub field, is going to actually be your on-chain Oasis identity address, and that's what's shown to you. And that's what we store locally here in the browser's local storage, but very easily as an application developer, you could also store it in your backend and use it to tie with any of your users' accounts.
Cool. So now we've got our user IDs and we can start building out our app, right? And doing things with user data and running compute. So let's hop over, I think, to the second part of our demo here, where we actually start generating some of these financial data and uploading it for end users. So Nikhil, tell us a little bit more about how we upload data for end users.
Yeah, let's do it. So as we touched on already during the account linking, there is several on-chain blockchain managed constructs that Parcel helps you manage. And the first of those is identities. So in the first couple of lines of that upload bank data function, you'll see that we connect to the developer identity address. So that's the address of you as like an application developer, and who is going to be uploading data on behalf of your users. And then we also pass in a user identity address, which is going to be the address for the user for your application, in this case, Charlie. And that brings us to the second blockchain managed entity that we're going to be talking about, and that's datasets. So you'll see that in the first few lines there, we can specify dataset metadata, including title and a metadata URL. And you can include any other fields there as well. And then we can use Parcel to upload a dataset. So when you upload a dataset, it's going to take in the file that you upload, and it's going to store it encrypted in Oasis managed storage. And the keys are going to be stored inside of a data set that's actually on chain. And the only ones that can access those decryption keys are the ones who have been granted access explicitly by the dataset owner. So yeah, let's take a look at what we're going to be uploading and then go ahead and upload it.
Cool. So we're going to be uploading this file called records.txt. So let's take a peek here and see what it is. We see we have some sample records here of the user's financial history that we're going to use to calculate our credit score. So we're using this piece of sample data here as we craft out our application and debug it. But obviously in practice, we would never want to be peeking at users' data. That's the point of using Parcel. So in practice, how this would really work is you'd expect that this type of function be running on your server, perhaps in like a full server backend, or even as simple as like a serverless function, and you take the data directly from the source. Perhaps there's an API you're retrieving it from, like Plaid, and that you're piping it straight into Parcel, so you as a developer never actually have to see or take ownership, take custody of such sensitive data for your users. So let's take the script that Nikhil's put together for us here, and let's give it a whirl. We're gonna upload those examples, and we're going to upload it again to that end user that we ran through account linking with. So let's go back here. We have the identity address here, and just to double check, we can also hop over to Steward app, and we can make sure that that is in fact the right identity address for our users. So we see here that I'm logged into Steward app as a sample user, and we see I have this identity address, and that it matches the one that BlockCred has. So we'll use that to upload data so that that user owns their data. So I'll hop over here in the terminal. We'll upload data to that address. Great. So it succeeded. That's awesome. Now we have an address back for that data set. Nikhil, tell us a little bit more about what this address represents.
Yeah, so that's going to be the address of a service on chain that corresponds with your data set. And that service is going to hold your metadata that you specified when uploading, as well as any decryption keys that were encryption and decryption keys that are used to encrypt your data set. So then all of the actual data is stored off-chain in Oasis managed storage, and then as somebody is trying to download the data set, you're only able to do so if you have the correct access permissions, which is managed by the data set itself on-chain.
Cool. And using our nifty little CLI here, we can actually double check all this information and see, like Nikhil was saying, that this address here actually, in fact, represents a data set. The owner is our end user. It was created by our application, and that there's a policy here that now grants access to the application in order to access this piece of data for the end user. And one last check here to really round out this part of the demo is if we hop back to Steward app, again, as the end user, we can also see here that we now have this access to this data set. So again, Steward app is the interface for end users to have a really simple, easy way to manage permissions, see data sets, see data history. We of course wouldn't expect end users to be using our command line interface. So here we go. Here's the data set, the banking records that we uploaded a couple minutes ago for our end user. All right, Nikhil, what's next?
Yeah, so going back to the code here. So I just wanted to touch on the policy that was there as part of the service. So just to be explicit, so these policies that Parcel appends to datasets are also on-chain services that specify programmatic access policies. In this case, it's a very simple access control list, but it could be more complicated if you want it to be. And yeah, that enables the developer identity to have access to datasets in the manner in which you grant them access. And it also allows the user themselves to download their own data sets.
Cool. That's awesome. Should we get into the exciting part? Should we start building out this credit scoring logic?
Let's talk about how we actually run jobs on Parcel. So we've compiled together this very simple credit scoring script. So as you can see at the top, there's example usage. So what you do is you'd run the credit scoring script and specify two command line arguments, a from dataset and a to dataset. So that from dataset is going to be a file that represents your credit history. In this case, it's going to be that super simple list of balance records that we showed earlier. And the to argument is going to indicate the output data set to which to write the credit score that the script computes. So yeah, so the script could be arbitrarily complex, but for the purposes of this demo, we've made a very simple application that just sums together all of the balances in the credit report and averages them. And if it is greater than $1,250, then you get a credit score of 722. Otherwise, you get a credit score of 684. And then it writes it to that output path that you specified. And yeah, the parcel will upload that as another data set that you as the user owns, and the developer identity does not own.
Awesome.
Yeah, let's go into how you do that as code now.
Cool. Let's run the super advanced credit scoring algorithm. I'm excited about this. All right. So now how do we get this actually kicked off and running on those set of bank records and running inside of our secure computing enclave?
Yeah, so in the previous step, we uploaded the records.txt file as the data set to Parcel. Now we also need to upload our compute binary, in this case, the credit score.sh file as another data set. That's going to do the compute for us. So that's that first step there. And then the second step is to actually construct a job request that will run the compute on the things that we want. So the command that is going to be run by our Parcel worker, the machine that's going to be actually running the job, is that block up there. So it's going to run the credit scoring binary and take in two arguments, just as we discussed, an input and an output. And so yeah, so we need to now tell Parcel where to find these files. And so we specify both the input dataset and the binary to execute via their on-chain addresses, and also the output path for the output dataset that we want to run. And so yeah, so once we submit this job request, it's going to be sent to our on-chain job dispatcher, which is going to then schedule the job to be run by one of our Parcel workers. And so these Parcel workers are going to use their secure enclaves and execute the compute within them and send out an output dataset that, again, will exist on chain. Once that happens, then we can actually download the output dataset and check out our credit score.
Nice. Let's do it. So again, I'm going to invoke this script from the command line, but you could also imagine that this runs in your backend and it's perhaps triggered by a user clicking a button or someone hitting one of your API endpoints in your application. And so we're going to pass into the script the identity address of our end user, as well as the address of that data set that we uploaded. And then it's going to use those as inputs to build out this new credit score. So like Nikhil talked about, it's going to craft together a job request and submit that off to our dispatcher. Nikhil, when the worker actually gets the job request and what is it doing behind the scenes? What is it doing inside that enclave to help us run this program?
So behind the scenes, it's retrieving the appropriate credentials for decrypting the necessary input data sets, in this case, the records, from the data set itself within the secure enclave. And then it's going to also, once it finishes the compute and uploads the output data set as a on-chain data set, it's going to set the owner of that data set as the user identity that we want it to be.
Nice. That's really cool. So we have the job running now. We have our job ID back for it. And hopefully within a few seconds, we're going to get back a result. And like Nikhil said, if the job succeeds, we'll get a success. And we'll also get a list of new addresses, new data sets that have been created by this worker that contain, hopefully, our credit score. So we see here that we got our job completed successfully, and we have one output data set. We've gone ahead in the program and we've pulled in that data set, that new output data set locally. And if we take a peek, it should have our credit score, 722. Nice work.
That's a pretty good credit score.
Savvy saver over here. All right, and to really round out the demo, we can also hop back over to Steward App. And like we said, Steward App is a great place for users to manage their data and see a history in access to the immutable ledger of all the different actions taken with their data set. So if we hop over to the data history tab here, we should now see access events that represent when the script, the app was going through and using the records to analyze the user's financial history and then create the credit score. And what's super cool is, like Nikhil talked about, is outputs can be configured such that they also then belong to end users. So again, as an application developer, if I'm working with really sensitive data, I never have to take custody of my user's data. So if we hop back over to the data tab and we refresh this, we should now not only see one data set that represents the initial bank records that we worked with, but also the credit score result that we outputted. And so now as an end user, I've got my bank records and I also have my credit score. So that rounds out, that completes our demo of Parcel. We hope you all found that interesting. We're really excited about some of the tools we've built here. We hope it makes it really easy for developers to build great, powerful, privacy-first apps. We are excited for end users to be able to own their data and still take advantage of great applications. If you as a developer are interested in learning more about Parcel, seeing a demo, trying out the package, reading through some of our documentation, visit our oasislabs.com, our website, click on the information about Parcel, and we're really excited to share Parcel with everyone. We hope you all found this interesting. And Nikhil, thanks so much for your help. This was really fun to build.
Yeah, I hope everybody has a great time playing with Parcel.
Cool. Thanks, everyone.
Thank you.